So let's do the integral of x to the 9th over the square root of 1 minus x to the 20th. If we look at the denominator of the integrand, the square root of 1 minus x to the 20th, that kind of looks like the square root of 1 minus x squared in the denominator for the expression for the derivative of arcsine of x. We can think of the square root of 1 minus x to the 20th as the square root of 1 minus x to the 10th all squared. So if we substitute u equals x to the 10th, the denominator becomes the square root of 1 minus u squared, which would be exactly the denominator of the expression for the derivative of arcsine of u. In order to substitute u equals x to the 10th, we would need to have a 10x to the 9th term in the numerator since the derivative of x to the 10th is 10x to the 9th. However, since we only have an x to the 9th term in the numerator, we should first take out a constant of 1 over 10 outside the integral and rewrite this as 1 over 10 times the integral of 10x to the 9th divided by the square root of 1 minus x to the 20th dx. We are now ready to substitute u equals x to the 10th. If we let u equal x to the 10th, then du equals 10x to the 9th dx. And if we substitute this back into the expression, we get 1 over 10 times the integral of 1 over the square root of 1 minus u squared du, since 10x to the 9th dx is replaced by du, and in the denominator 1 minus x to the 20th is replaced by 1 minus u squared, since u equals x to the 10th. And x to the 20th is really just x to the power of 10 all squared. 1 over the square root of 1 minus u squared is the derivative of arcsine of u, so the integral of 1 over the square root of 1 minus u squared is arcsine of u. So the expression becomes 1 over 10 times arcsine of u plus the constant of integration c. If we substitute x to the 10th back in for the u, we get 1 over 10 times arcsine of x to the 10th plus c. So the integral of x to the 9th over the square root of 1 minus x to the 20th dx is 1 over 10 times arcsine of x to the 10th plus c.